Oh, hey, it works now. Hello to all of you at home. Welcome to this year's installment of the Technical Animators Workshop. We're about to take a journey together into the world of things like rigging, scripting, and problem solving. After doing this for the first time last year, there was actually such a great response from everyone watching on Twitch that Mike and gang invited us back, and all four of us are very excited here for the second installment of this. I'm really happy myself to be back. I'm even more honored to be joined by a new cast of characters around me. We have Evan Cox here to my right, Randall Hess to my left, and then Nina Fricker to my immediate left. And I myself am Brian Viniski. We are all TAs, and we are working with animators and all things animation tech related. So the format for the next hour is that each of us has a short presentation to give about something related to technical animation. These will range from around 6 minutes to 12 minutes and are meant to give you an insider look into the things that we deal with or have dealt with in our day-to-day work. After we've done that, we're going to open up a Q&A with all of you via Twitch chat at home. So keep in mind some questions you might want to ask the group as a whole or even just one of us individually, and we will try to get to as many as possible at the end. I will warn you, though, that if there are no questions, we will be forced to talk about our own individual techniques for painting skin weights for a good 25 to 30 minutes. So if you want to hear that, we will do that. All right, enough of me blabbing on. It's time for Evan with Flow and Repros. So time to play some musical chairs.
Oh, all right, we're doing it.
We're doing it. Yeah, can't move that.
Hello, it is me. Relearning PowerPoint. All right, here we go. Oh, spacebar. Yeah. Got it. Cool. Hello, my name is Evan Cox. I'm a senior technical artist at Bungie, and I'm here, as Brian mentioned, to discuss flow and repros. But more specifically, I want to talk about some philosophy, and also a little bit of like a practical example, because philosophy is sometimes a little bit much. So philosophy specifically around my 4 basic rules for developing tools. So I'll just jump into it. My first rule is if you can use the existing tech, you should do it. And also, a sub-note, write your own tech in a way that it will be easy for someone else to leverage it. Processes can change, so your deliverables can also change, so your tools need to be made in such a way that if those things do change, it can change with your deliverables. Yes. So you should develop those tools and those workflows and those pipelines in flexible bite-sized chunks. It's also great for reuse that way. You should preserve a user's flow as much as possible, so no wieldly set of confirm dialogues. For example, ask yourself, how many clicks does it take to actually export an animation clip? It's a very critical question to ask. My last one is, your tool should always be shippable as soon as possible. So get something that's usable, even if it's just a string of Python that you can go and cast on somebody's machine really quick and solve their problem. It's incredibly important to make yourself useful as soon as possible. As tech artists, we're not always given dedicated time to work on a problem. We're given probably like an hour or a day at most. So when you start a project, you should try and get yourself usable. Get yourself something useful so that somebody else can come in and use your tech, finish your tech, or hopefully you can come in and actually do the rest of your vision. Fun side note, this also happens to be similar to how I approach playing Tetris. So you leverage whatever you've already put down, you develop it in a way that you can react to new pieces as they come down. You always stay in that flow state, and you're always ready to drop that line piece, So you got to be shippable. Spacebar. Nope. Okay. On the flip side of this, I also have a philosophy for how a tool should be to use. So in an ideal world, the tool you're using should be easy for you to learn. But some tools are complex, but they should be well documented. If it's not easy to use inherently, it should at least be easy for you to find resources for that tool. For an example, is a hammer and a cockpit. It's very clear looking at a hammer what you should be doing with it. Right? You use it to hit things. With a cockpit, it's like, you know what it's supposed to be used for, but like, how does it work? Like, who knows? But there's probably a really nice manual somewhere. that you can use to learn how to use it. Your tool should also be simple to use, hopefully, right? A cockpit is really complicated, but it's really just a bunch of levers and flips and buttons and screens. It should also be clear when to use the tool and when the tool is done, when the tool has landed. Whether that's with like little pop-up notifications or just like, hey, I know I use this tool when I need to bake something down or I need to flip the space in this tool. Your tool should also produce the expected results. I feel like that should go without saying, but it should inspire confidence when you're using it. When you click a button, you should know what that button is going to do for you and what you should expect after that thing is done processing. That's critical. So I have an example of this, and I want to kind of root it in something that maybe you can see yourself in this scenario. Production realities are real, bugs are real, they don't often mix. If it's not really that easy to communicate, external pressure to push past it and find a way around it, problems may not be logged, right? They might be logged on a piece of paper on your desk, they might be logged, I don't know, in a meeting somewhere that you hope somebody will talk to your production staff about. But, we should log these things. And this is less of an animation content problem as more of a workflow and efficiency problem. So we should ask ourselves what kind of solutions exist for this task tracking / notification system. So I wrote a tool called the Repro Wrangler, which is a simple little error reporting repro gathering system. If you're not familiar with a repro is a set of instructions and data that you can give to a tech artist or a programmer to reproduce your problem. So with this tool, you're able to skip the back and forth and just run the tool, type a little bit of description, and get back onto it. So the user chooses from a list of available recipients, yours may vary, tells them what happened, what they need to resolve, and you click send. You get on with your life. Easy mode. The tool itself saves the scene to a networked shared drive, sends some scene description emails, and it includes your write-up or whatever else you want to have in there. I think mine says whether or not there's a party mode in Maya, if I have some session loaded, and the last time that the scene had actually worked properly. But you can expand it. You can have it say, oh, this is how many rigs are in the file. We know we have problems with how many rigs there are in a file. Or a play blast of before and after. I don't know, whatever you want it to do. But there are some caveats. So whoever wants to, you can build in auto task management into this, right? I don't really know if you should automate this process. I personally never really looked into this, but it seems like something to me at a glance that should still be a manual operation that I want somebody at the other end to say, this is what I was expecting. This is my context. And realistically, some production environments may just not be a good fit for this. But of course, these are just things that you can build upon. Again, the data is something to be changed, but also maybe the surrounding environment. But that being said, I feel like these are pretty okay caveats for a tool that took only 45 minutes to spin up. Because, it fits into my next point of this leverages the existing tech of sending emails, querying scene data, and saving files. And it's getting very bright. But this fits into my philosophy from before very well. Because of that, it is also a very small, bite-sized chunk of a tool. It's intended to be built upon and leveraged in new ways. It's shippable right now. It's an easy interface to understand and operate. If you can write an email, if you can check a box, you can use this tool. It produces emails that contain your description and more. So it produces expected results. It kind of looks like an email client, so you expect an email out of it. And it reduces the need to leave the DCC of your choice to communicate an issue. So you're in Motion Builder, you're in Maya, you hit this tool, you type a little thing, you click send, you're out. You don't leave your flow state, and if you do, it's only for a brief moment. So, 2 things to take away from this, from my talk, I hope, is that flow is incredibly important. I try to design all of my workflows so that they let people stay in their flow state. If they spend all day in an app doing what they love to do, whether it be animating, modeling, I don't know, for me it's like doing Python stuff. I want to stay there, all right? I don't want to jump over to write an email to someone. I don't want to jump over to Skype for Business or whatever proprietary messaging system you use. Minimize the mental shifts required to go between workflows. And if they have to switch, make it easy for them to learn, switch, and get back to the one that they actually prefer to be in. Also, you should develop simple solutions to problems if you can. So you should seek those out. Those simple solutions should be developed in a way that's easily expandable and at the very least minimally viable very quickly. It's much harder to make a complex thing simple than it is to increase the problem scope of an existing solution. And that's all I have to share. I'm Evan Cox. I have a lot of opinions. Feel free to at me.
Hey, Evan.
Yeah.
Have you ever employed anything that you just talked about in a real production pipeline before? And if
I have.
so, what production pipeline?
When I was at Volition, I wrote a tool called the K-Saver. Our K drives were our networked shared drives. And this actually came out of a problem that, we were having issues with using task management and all this stuff to translate DCC type bugs around. And so I spun up this system, little email client, and it worked great. And I also have a standalone version on my GitHub that I'm about to make public so that you can download it. It's all stubbed out. You just need to slot in like your messaging client of choice. And then it should be good to go.
Very cool.
Yeah.
Thanks, Evan.
Thank you. Randall?
So next up is Randall.
Hello, I am Randall Hess. I'm a senior technical animator at Epic Games. Prior to that, I was at Boss Key Studios for several years, and these are some things that I wrote to kind of solve problems that I had personally as a technical animator. The title is called Creating Autonomy for Artists because I think it's important that artists have the ability to be independent and get their work into game. So this is essentially removing the tech animator me from being a bottleneck for artists. With a small team and many assets being created internally and from external outsourcers, a lone technical animator become a bottleneck for implementing assets into game. This not only slows down the assets being tested in game, but can reduce the immediate iteration time for the artists creating the assets themselves while they are actively working on them. We ultimately want the artists to have the ability to export and implement the assets into a game when and where possible. This means we need to remove the technical animator from the process. So how do we solve this? As a technical animator, we should know what it takes to get the assets into the game. We have many processes and tools that we use to streamline our workflow for getting the assets animation ready and implemented into the game. What we need to do is put this power into the hands of the artist to a certain degree. We need to determine what processes we can wrap into a simple user-facing tool. We need to outline the steps or sections in the tool that we cannot automate that will require manual input or creation. We need to understand not only the capabilities of the artists, but we have to respect their time and make sure they don't feel as if we are throwing our work on them. So here's an example of a tool that I wrote for character art to kind of simplify their process and take me out of being a bottleneck for them. This tool allows character artists to quickly set up new customization items, implement them into the game, and iterate on their own where needed. The tool is created to be incredibly simplistic as to not overwhelm the artist using it. Is a dynamic UI that walks the user through the process, which also keeps the flow of the tool very clear. There are plenty user-facing tooltips and informational buttons that can be used if the artist is unsure how to proceed. So here's just the demo. So it's pretty straightforward. The artist just simply inputs the mesh, gives the asset a name, and sets the section of the customization asset to upper body in this case. Then the follow-up button was add the rig to the scene and skin the mesh. So far, I've already gone through and skinned 2 separate customization items, and they've been validated and exported. This is obviously sped up a little bit, but as you can see, the steps in the workflow is actually pretty simplistic. And they can even go back and run an animation ROM on their skinning just to make sure everything's looking correct. And then obviously now it's game export ready. All right. This does not remove the tech animator entirely, of course. After the mesh asset is in the state where the artist is comfortable, the usual follow-up task of the rigging artist will still be employed to bring the asset to completion. So I'll be tweaking and skinning in armpits and crotches forever. So no lack of that. This example is for the weapon art team. I have a weapon artist, and all his weapons went through me in Lawbreakers, and I wanted to get to a point where he could actually do the process himself. This was a tool I had previously written at Volition, and I wanted to get it in place at Bosky. It was created to give the weapon artists the ability to set up, export, and implement their weapons directly in the game. It was designed to keep most of the actual rigging out of their hands, as it was mostly created behind the scenes while they worked through the tool. It leverages the construction of separate pieces of geometry and their own pivots for rigging. Almost all weapons and props for this previous game that I worked on were created and implemented by our weapon artist, and they were all animation ready. So here you can see the artist inputs the weapon name. It creates a basic rigging hierarchy, and they can place the secondary handle location. You can see now the tool is only asking for a mesh input initially, and it's using those pivots to create joints, and the user can customize the animation controls relative to those pivots. The UI is lighting up in certain places, say it can add the mesh if it's got all the information it needs, or if you want to add a custom input, you're free to do so. So for every little piece that's going to move, it's a separate piece of geometry, and the user's just plugging that into the tool. And as you can see here, they got all the pieces set up. Each have their own animation control, and the tool validates everything, and it's export ready. And this one on its own takes about 5 minutes or whatnot. So that was really useful. Next up, now that our assets are being exported and managed by rigging tools, our asset launcher can now bring them all together for the animators. The assets populated in these lists were mostly artists created. The technical animator need only polish tasks to clean up the rigs and skinning, while the art team can continue creating and iterating on their assets. In this example, the animator can load the character, weapon, and customization outfit that they'd like to construct their animation scene with. So we are adding the character. The customization browser sees all the types of assets that are available. The user can pick them, load them to the scene, get some awesome hair, because that's important when you're animating. And load your weapon, and then snap the weapon to the hands and make sure it's following how it would in game. And you're off to the races. And with this kind of tool set in place, artists can feel free to create whatever awesome animation. And that's it. This is all customization and animation, obviously done outside of my doing. So it was a great thing to get implemented. Gave me time to work on the assets that I need to focus on, while allowing the artists to be empowered and create the tool, the assets that they needed to get in game. That's it. I would like to say thanks to Animex. This is really awesome. And I'm releasing the code for the item rigger for what we were just showing the weapon creative with. There's a GitHub link for that. You can check out my blog if you need more information on that or whatnot. And hit me up on Twitter. I'm Meatplouse.
Hey, Randall.
What?
When you made these for the artists, how long did it generally take to train them up?
They're pretty quick. I mean, as long as they're written in a way that is very user-facing and intuitive. I probably walked our weapon artist through 2 assets just to show differences in like how they set it up, and he did probably all the ones in that list, which were probably 35, all on his own. I never touched any of them.
So you didn't have to rig ever again after that?
No, I wrote myself out of the job. So, yes.
Very cool, very cool.
Thank you.
Thanks. All right. Now up is Nina Fricker.
Is this thing on? Am I good? Can you hear me? I hit the button. Okay, great. I'm good. Thank you. Okay. Sorry, I don't want to like tear everything down as I'm moving around here. My name is Nina Fricker. I'm the lead character TD at Insomniac. If you haven't heard about us, we've made a few games over the last 25 years we've been in business, all the way back from Spyro the Dragon, Ratchet and Clank, Sunset Overdrive. We're in VR space now, and you probably heard about Marvel Spider-Man, which we released this past September. I'm going to be talking about pipeline tools standardization. It's very exciting. So this is, I want to put out there, this is not just my work. This is the work of my team. We're an extremely collaborative group of people, and particularly the tools that I'm going to be talking about today. Our senior character TD, Derek Lewis, did a lot of the heavy lifting on this tool, so I just want to make sure that credit is out there. So let's talk about the problem that we were solving. At Insomniac, because we have been making games for such a long time, we have a lot of tools, like a lot of old tools, new tools. So we're supporting a pretty large code base all the time in the character TD department. And so the problems that we were solving is how do we, one, increase quality and consistency? If you take a look at our tool set that's been developed over the years, a lot of the implementation of simple things like help menus, help messages, error messages has been kind of all over the place. There's been no standardization. Also, we want to optimize the way we go about creating tools. Right now, everyone has, well, before this, everyone had to essentially implement everything themselves from the ground up. As we're getting more experienced at developing tools, we've come up with like a baseline set of things we want in every tool. Like it should have documentation. And as this list grew, we were finding it's kind of a bear to like make sure every single tool you write every time has all of this implementation in place. So we wanted to get faster at that. Let's see. So let's enter base tool. So I know, just bear with me here. So what we created is a tool class that all of our new tools could inherit from. And what we did is we packed it with a bunch of features that are just ready to go out of the box. Also, we've got this beautiful wrapper with our nice new logo and our little icon in the corner. So for us, this meant like being able to present our tools in a little bit more professional light. I don't know if we start taking a look at our older stuff, it's like really checkboxes everywhere. I will say for animators, that logo, we can turn it off if you really need the screen space. Like it's always a negotiation. So that is an option that we can easily toggle. Just, I know you're thinking it. So what kind of features? I'm going to go over a lot of these in a little more detail. But so overall, consistent menu items, standardizing the output to the user so they know what's going on, standard progress bar, status line. I know. Okay, so to start with consistent menu items. So every tool that we write that inherits from base tool has a link to documentation, which is required. This has like become something that you cannot check in your tool unless you have documentation written, which is a great thing. Content users can also take a look at what existing issues exist for the tool. So if they click that second item, it'll just take them out to our tools database and show them what's already been filed. So if they do find an issue, they can tell if it's been bugged already. They can request a feature and report a bug, and also just send us an email. Like if they, I don't know, have something on their mind they want to tell us about, they can just do that from right there. The output window is actually one of the most exciting features to me and my team because we geek out over this stuff. So what this is, it gives us a consistent place to report information back to the content user. Historically, you've, I don't know, write to the script editor, status line, all that, and like nobody ever sees it, or they see it and they ignore it, and you'll find out like a week after you're push out some tool update, and artists are like, yeah, it just doesn't work, and I don't know why. So this output window lets us, one, everybody knows exactly where to go for information. We also can color code it, which is cool. Red means bad, right? Green is good. Yellow is like, I don't know, it's a little weird. So because this is available in every window, like everyone knows where to find it. Let's see. I'm going to show you a little demo, which, let me, spacebar, promise. Okay, so here's a demo of, it's just a prototype tool that we put together that runs a little demo that shows like, hey, here's progress bar going, here's a warning, here's an error. So this just shows off some of the features with the output window. You see I clear it, run it again. And so here, we can provide users valuable information about what is going on with the tool, sort of like what Evan was talking about, right? Like, let them know that it finished, We also have, specifically in Maya, we also write to the viewport. You'll see this little dialog area that comes up at the bottom. Again, just so people don't miss when important information goes by. That was a pretty cool feature that got added in there. So here's a few examples of some of the tools that inherit from base tool. This is our assemble scene tool. Animators use this to like pull different actors into a single scene so they can animate it together. This is our rigging tool. It's called Rig It because we are very creative. Let's see. This is our character picker. So this is what animators use when they're animating with characters to select all the controls. Oh, what's wrong with it? Okay. Better? Okay. Great. Let's see. Spacebar. Yeah. Okay, so this has all been like a great development for us, but we kind of took it a little bit further. Thanks to Ilan Ruskin, who got us a Python distribution available to the entire studio that the tech art team can call on. And you should check out his talk on Thursday about a technical postmortem of Marvel's Spider-Man. So with this Python distribution, we were able to take base tool and abstract it out of Maya and actually make it available for our other tech art tool teams to use, one in conjunction with other DCC apps, so like Houdini, Substance, and then also to write standalone tools. So like we've kind of leveled up in that like we're not just constrained to the Maya environment anymore. We're actually developing tools outside of Maya, which this is an example. This is called Proxy Swapper. Again, Derek Lewis wrote this for our upcoming VR title, Stormland. This is used to like procedurally populate level geometry with like a bunch of different variations. And you can see it's got all the same like features. It's got the little output icon that pops up in the output window. I know it kind of kills him that the style doesn't match exactly Maya, but he'll be okay. So that's kind of it about the tools. I wanted to throw in this extra thing because we find it extremely useful and it's kind of fun. We set up this custom exception hook when we start up Maya that basically kind of spies on all of our content creators a little bit. They're nodding, yeah. And what this does is it catches any unhandled exception that a content creator will hit in our code, and it shoots an email to a mailing list with a bunch of information. And what this does is this lets us know when people are hitting issues really quickly, way before they're going to bother telling us. So we'll start seeing, if someone checks in something not great, which happens, we'll start seeing these error messages getting reported to our mailing list, and sometimes like there might be a lot or a few, but we can immediately jump on them and be like, hey, what's going on here? This exception, it will shoot us all kinds of information, like what project you're on, what tools release, who you are, what file you're working on. It really freaks people out when we show up at their desk and be like, well, hey, what are you doing with this file? And why are you sending 100 errors? And they'll be like, what? Like, how did you know? But it has allowed, having this in place has allowed us to respond extremely quickly to problems, like I said, that I think we probably might not have heard of for like a day or two. So spy on your artists. That's all I have. Thank you so much. Thank you, Animex, for having us here today. It's been very cool. We are hiring. There's a link right there, particularly on my team. So if this stuff sounds exciting to you, please apply. Love to hear from you.
Hey, Nina.
Hi.
How are you?
Good.
That was great.
Thanks.
Curious, I'm a new tech animator at Insomniac Games tomorrow. I need to write a tool. How long would it take me to grab this base tool that you've created and whip up something using that UI? Say a simple, couple hours for a quick script. How long does it take me to integrate that script into your base tool?
So if you've already got your functionality and your whatever UI you want to plug into base tool done, it's really just a matter of minutes. You just need to stand up some initialization to tell it like how it fits into our menu builder and what commands to run, and like that's it. It's ready to go. It's awesome.
And when you spy on your artists, is it usually user error, or is it a combination of user error as well as tech art?
Well,
or tech
according to that
animation?
talk we saw today, it's never user error.
That's not true.
I would say it's a mix. Yeah.
All right, thank you. All right, we have to play musical chairs now. Yeah. Thank you. All right, good. All right, I'm going to go last. All right, as I stated before, my name is Brian Viniski. I'm a senior technical animator at Avalanche Studios. I've been there for almost 7 years now and have been a part of the 2 most recent installments of the Just Cause series. So for my little bit here, I want to try something a little bit experimental for Animex. Not sure this type of presentation has actually been done yet within the 3 years of Animex existing. So I'm going to make everyone guinea pigs. Don't panic, though. What you're about to see may be very disturbing to animators, like very, very disturbing. In fact, it probably is, because it involves showing you Python code. Now, let me preface this. Last year, I was chatting with Richard Lico, and for some reason, we started talking about foot planting. And for those of you who are not familiar with Richard Lico, he's a fantastic animator who worked on Moss. You should play it if you haven't played it. And on Just Cause 3, our animators had to manually mark any footsteps in their locomotion animation. And in talking with Rick, he mentioned that he had to manually set footsteps too, and also how much he did not enjoy doing this. I also started to find out that many other animators at other studios were also manually tagging footstep data. So when asked to be part of Animex again, I came up with the idea to show that as best as I could. An automated process, rather, that I came up with for tagging footsteps. Now, I promise I'll do my best to not get too codey with my explanation, but I am going to show some code for anyone who is, in fact, interested in that side of it. And keep in mind, too, this is all in Maya. So, back on Just Cause 3, anytime we wanted to get footstep data from a file, we needed to have an animator go in and actually manually tag whenever that footstep occurred. They had this fancy-looking tool here that allowed them to scrub through an animation, click left plant, click right plant, click left plant, click right plant, and keep going and going. You can see the red and blue footsteps here, or the placement markers here that are getting set whenever a foot hits the ground. Now, while this was pretty simple and easy to do, it was pretty monotonous and took up lots of extra time that actually took away, say, from actual animation work being done. And as a tech animator, it's my job to make sure that the animation team is in fact animating and not doing boring processes like this. Now in JC4, I wanted to take this out of their hands and automate the process. What I came up with was this script. Please don't be afraid. You don't have to read this. I also, in fact, encourage you not to read this. I'll go through it step by step, I promise. Now, this script stands about 88 lines total. It includes all comments, all the comments here, which are green, and takes up about half of the space, so it's really not as long as it looks. And I'm also not telling you to panic, because, yes, this is going to get broken down into more pseudocode, and you don't actually have to read the lines of code to understand what's happening. So let's start digging. The first thing that we need to do here is find the distance between the ankle joints within consecutive frames. For example, let's say you're looking at a run cycle, and the left leg of a character is swinging back down to hit the ground. On frame 7, you grab the position of the left ankle joint in world space. Then you grab the world space position of the left ankle joint on frame 8, and you calculate the distance apart that the ankle joint has traveled between those 2 frames. And guess what? You don't even have to do math to do this. My secret, in fact, is that I found myself this handy little distance between function simply by Googling Python distance calculation function. Sure, I could have written it myself, but why do that when it's already out there? So this bit of code was actually the major cog that ran this machine. Now here, we're just saying that we want to evaluate the left and right foot joints, and then depending on an animation being a walk or a run, there's a predetermined threshold that is slightly different based on the fact that the distance each foot moves, depending on the gait of the character locomotion, is pretty different. If you look at a run cycle, the ankle joint will have a further distance between the frames than a walk cycle. So what does this threshold actually do? Well, we know that when the foot is actually planted, its position doesn't change a whole lot from frame to frame for a few frames. This value simply will say, do not bother even looking at anything greater than this. It was sort of a hacky but efficient way to filter out any obvious non-planted values, as sometimes those can otherwise mistakenly get tagged based on the character's leg movement when it's not planted. And here's the bulk of the script that takes these factors into account. We analyze twice here, one time for each foot. The analyzation goes through timeline, finds the current value of the world space position of the foot on each frame, and compares that value with the world space position of the foot from the previous frame. If a distance value is less than the frame before, as well as less than the frame after, we tag that frame as the planted foot, or the foot is planted. By tagging the smallest value of movement in a particular range of values, we assume that the script has found a planted foot. For walks, we also added a filter that made sure a foot wasn't too drastically rotated up or down or twisted, since the slower nature of walks meant that the distances of the position of the feet weren't as drastic from frame to frame. And surveying both the pitch and roll of the foot gave us another good indication that a foot was planted, as it ensured that the foot itself was flat on the ground. Another really nice thing that we could do from here is take that footstep data that we gathered, and depending on if an animation is a walk or a run, determine when you would hear a cloth sound. The character almost always hits the point where their legs cross each other after a step at the same time, whether it's a run or a walk. For runs, it was 2 frames after a step, and for walks, it was 5. Thanks to this consistent behavior, we can automatically gather cloth sound triggers, and not only are we gathering footstep data, but cloth sound data. This made both the audio and VFX teams very happy, as now they don't actually have to worry about manually tagging these things in the game themselves as well. They were also already benefiting from those automatically tagged footsteps. Now, to the surprise of myself, VFX, animation, pretty much everyone that used this or got this data, this method had an insanely good success rate. I'd say about 90% of our footsteps and cloth were tagged correctly. The rest was manually fixed, as sometimes extra footstep tags snuck their way in, or a tag here or there was missed. However, the amount of work to do that cleanup was a million times less than what anyone had to do before when we were manually tagging footsteps. So now let's see this in action. Here we've got a run animation. By quickly scrubbing through here, we can see where the foot is being planted. Here it's about frame 8 or 9 for the right foot, 18 for left foot, so on and so forth. Now we run the script, and it cycles through the animation as it evaluates each foot. When it is done evaluating, we get our auto-generated footstep tags. Now, let's actually test how accurate this really is. All right. Right foot is planted about frame 8 or 9. Left foot about frame 18. Right foot about 28, 29. Left about 37, 38. Right about 47, 48. Left foot 57. It was close, right? Huh? And just for fun, let's evaluate 4 feet and run this script on a llama, because everyone loves llamas. Hey, we got data. Look at all that sweet data. All right, now let's test this one out. We've got a right rear footstep around frame 6 or 7. A left footstep in the back around frame 8 or 9. A right front footstep around frame 10 or 11. And then a left front footstep around frame 12. All right. Now, there are some caveats of the system. First off, it's not perfect. Some manual work is necessary to tweak inconsistencies, but it's far less work than actually marking foot plants everywhere. Also, animators need to make sure that they've got nice, clean animation curves, which in the polish phase of animation shouldn't be a problem anyway, especially when you're using Maya and have the graph editor right there to show you that you actually have nice curves. Finally, this system does need extra love when analyzing walks due to the smaller gait that a walk entails, meaning that frame by frame, the distance between the 2 points is much less, and at certain points it's much easier to be mistaken as a planted foot. Remember, I had to add that special filter for walks just to help with accuracy. Regardless, this auto footstep tagging system was pretty darn accurate and did save countless hours of manual work. So I hope this wasn't too crazy for anyone here or anyone at home. I did want to try something a little bit different and a little more in-depth as far as tech animation goes. I have seen on the AnimState Discord that there's a lot of people who are interested in tech animation, whether it's getting started with rigging or getting started with Python code. So hopefully this gives you a little bit of an insider look at a problem that we solved through Python and through automation on Just Cause 4. Now, if you want to know more, I'm happy to share. I'm sure anybody with me here is happy to share more things like this. Please let us know. We would like feedback about any of the things that we talked about here today. And if you want more of it, don't want to see it ever again, especially the code, but maybe you do want to see the code, we're happy to share. Like Randall and Evan said, they're going to share some of their scripts on GitHub, and we're going to start kind of opening up ourselves more to that. So yeah. Now, that being said, we have about 15 minutes for, 15 to 17 minutes for some questions. We have some questions. Thanks. We got 2. Which is worse, skinning armpits, crotches, or retopo on ears? Oh, Randall's got the mic.
I'm going to have to say armpits. It's been a pretty hot topic for us recently, and it's always a challenge. A lot of it has to do with how the model is rigged or delivered in kind of base pose. When the arms are down close to the chest and the torso, there's a lot of compression of vertices inside there. So, and it also matters how you're baking normals. So when the arms come up in game and the normals were crushed in a certain manner and they don't recalculate normals, then you have difficulty, making that look really good. So I'm going to say armpits. Yeah.
Have you ever used the hammer weights function in Maya?
Yes.
How does that work for you?
It kind of works. It doesn't fix all things.
All right. Does anybody else have any ideas on that, or you kind of agree? Oh, Evan has an idea.
I have a thought. I got thoughts, Randall. I got thoughts. I agree, but I think a retopo on ears is harder than it sounds, because skinning armpits is just skinning work, which is, it's skinning work. It's tedious. But a retopo on ears, depending on your pipeline, that means potentially vertex count, vertex order, all these things are changing. And if your phase pipeline is vertex order dependent, that's a lot more work. That's a lot worse.
They can't change the vert order, man.
They're saying retopo, man. It could be anything.
If they can't change the vert order, they can't retopo.
What if you retopo in the ears?
Well, then you have to change your system.
I'm just saying that's a little worse.
I say no.
All right. I got strong opinions. Get at me on Twitter.
I think Nina and I need to step back for a second. Full disclosure, Randall and Evan worked together for a few years. Yeah, they buds. Yeah, a few months. All right. All right, another question here. What would you recommend for a student interested in technical animation who doesn't have access to a big pipeline with interesting challenges to solve? Anyone have a
good question?
Matt?
I think it's definitely worth reaching out and I've seen the same question on Twitter many times. It's definitely worth reaching out and asking others this same exact question. And a lot of what I see is try to emulate something that you see other people do in their demo reels or blog posts. Do the exact same thing that they did on their blog post, the exact same way they did it. And as you're working through it, you'll see why they hit certain problems and how they're solving them. And I think that's really beneficial. Emulating something that somebody else already did, even in the tools that I showed, I had written those before at Volition. I had to write them again because they didn't exist at Bosky. You know, writing the same thing that somebody else has written is not, you know, uncommon. It has to be done, and you may end up in that situation where you have to rewrite something. So I think that's a good step forward.
I mean, also, if you hit up any of 4 of us on Twitter, we've come through some challenges. I mean, I'm happy to kind of give examples of challenges and kind of give maybe like an example that you can try and solve at home of something that's like small and doable.
Yeah, talk to Brian.
Yeah, talk to me. Sorry, I could not stop laughing when I saw this question. Randall, how many Frappuccinos have you had today?
Jesus Christ. None today?
Is that a completely random question, or is that something that...
Well, that's
Is
a
that
targeted question.
targeted
I know what's happening here.
Just so you know who may have asked that question. Okay.
I have a pretty good idea. Thank you.
Hey, this one's for me. Was this markup entirely in the DCC, or could you have built it for in-engine content as well? Also, for anyone at home that might not know DCC, it's just digital content creator, like Maya, Motion Builder, whatever we may be using. So yeah, that versus in-engine. I did not personally write it for an engine. I don't see why it wouldn't be able to be in-engine. I'm pretty sure on Just Cause 4 we did have a programmer that wrote something that calculated some footsteps for our NPCs. I think it worked pretty well, but this was specifically for Rico and player character animation that was pretty much marked up a lot compared to the NPCs that weren't quite always marked up. So I guess the quick answer would be no, I didn't write it myself for an engine, but yes, it could be written for an engine. I also think that there's plenty of room to make it better as I kind of whip that script up sort of quickly, and I actually made it a little better in the past week just working on the presentation as well. But yeah. Oh, this is for Evan. Go ahead. Oh, God. Evan, how much of your diet consists of ginger candy?
You know, I've been self-medicating for a while. And
So funny story, I actually did. I had a ginger chew like 2 days ago. Like I was like laying on the couch. I was about to get on my flight. I actually almost was late. I actually almost wasn't here because I was like, you know what I should do? I should have a ginger chew to like invigorate the body. Sorry, this is like really not a technical question at all. I love ginger chews. They're the best.
Okay, I have a question for the panel, since right now we don't have any questions in front of us from any of the viewers. Is it harder to explain what you do to a programmer, or is it harder to explain what you do to an animator?
I think animators understand us. They get what we do because we help them a lot. I used to be an animator. I know what it takes. And having somebody that supports you directly is terribly beneficial. Programmer, maybe a little less. It's interesting because in so many ways, I think we speak the same language. You know, we have similar problems with, you know, doing scripting and tools, and I think, you know, that goes a long way with, you know, making that communication easy. I don't know if you're a tech animator and you have a bad problem communicating, you may be in the wrong position.
I would agree. I think programmers have an idea of what we do, but in terms of getting into the nitty-gritty of like Maya, for example, I think animators are a little more in tune with what we're doing. Is even though we're doing a little more technical work, like I think they grasp sort of the core functionality that we're bringing to the table. Or I think programmers are just like, I don't know, they make stuff and it gets exported.
I also find that animators are like genuinely curious about what we do, even if they don't have any idea of what we're doing. I know the animators at my studio, we have one sitting right in front of me here. They ask genuine questions about how things work, and they want to know why things work. And I know just with my team at Avalanche Studios in New York specifically, they don't hesitate to ask why I'm doing something or how I'm doing something, because they want to know and they want to learn those things. They want to get a little technical and kind of whip up some scripts if they need to help themselves, because sometimes they don't have the time from me to give to them, because there's more of them than there is of me. Okay, here's a legit question, not about ginger chews or frappuccinos. What is your favorite or most elegant solution you came up with for a technical problem?
It's a really hard question.
I mean, for me, the footstep stuff I was pretty proud of, but I mean, I just showed that to you, so that's not the best probably example here. But I guess an elegant solution to a technical problem for me. Ooh, this is so tough.
Here's the
Oh,
thing.
Nina's
I don't
got
do elegant. I do scrappy, quick, dirty, fast solutions. So that question is not applicable.
We're super hacky. I don't know,
Well, sometimes you just got to get things done.
yeah, I don't think I've ever written a tool that's clean.
Yes.
I'm pretty sure every time I write something new, I look back at my code and I don't know why I did what I did. Oh, Evan just had an epiphany.
I have one idea. And it supports the same narrative we're all saying. So at Volition, we had P4 lockdown, so you couldn't check anything into the depot. But we also were working at the same time because we were wanting to ship the game, And we had a milestone after that milestone. And I had checked in a tool literally hours before the P4 lockdown that broke everything. Not good. Now, I was never going to let that happen again. So what I did was I wrote a tool that from our motion builder, it would reference a drive on the network storage that would then be updatable. So I could send patch updates. I would get past P4 basically. So I could still hack while everything else was broken or everything was locked out and I couldn't check in code fixes. So I'm pretty proud of that.
You should be.
Thanks, man.
I'm there for you.
Yeah. Yeah, it's not really that elegant, but it supports the. It's cool. I feel like tech animators especially, we're just, like you guys were saying, we're just making it happen every day.
We solve problems.
Yeah.
All right, we got 2 quick questions. We got a little less than 5 minutes left. I'm going to start with this one. If somebody could answer, what is your planning process when spinning up a new tool?
Oh, that's interesting. Had a friend of mine when I started learning scripting. He was kind of mentor Kelly Snapka. He worked at Volition with us. His kind of approach he showed to me was, before you start writing anything, write down comment blocks of what you want to solve, and those comment blocks, I want to do this, then I want to do that. Those become your functions in your tool. So as you're populating your tool, you're filling in under these comment blocks. So you've already set the template for how your code is going to be set up. And I still follow that to this day. And because a lot of problems you have with starting something is actually starting something. And I think throwing down, your high level, it's just like the same thing. Write a list of what you want to do that day and mark everything off. It's the same kind of concept. And I think it's really helpful.
That's elegant.
Yes.
Very elegant.
Yeah.
I like it. I mean, we're so used to hearing the term pseudocode, right? Where we just write down what we're going to do, but then we just kind of destroy that and get rid of it.
Yeah.
But this is you're actually creating usable chunks of things that you can keep in your tool.
Yeah.
That's awesome. All right, final question before we break. And I'll start off with this if any of you have anything to add to it. What inspired all of us to move to the technical side of animation, and was that always your chosen path? So I went into a college program where it was just kind of general animation. You did modeling, texturing, rigging, animating, rendering, everything. You kind of figured out if you wanted to do games or film or whatever on your own. You almost had to learn how to rig on your own as well. So I kind of taught myself how to rig. I watched, at the time it was Digital Tutors videos, or looked online for tutorials. I had a teacher who was an animator, and he kind of wrote this rigging tutorial for all of us. And for some reason, I was just much more into that than the rest of my classmates in school. They could actually draw. They could actually animate. I could not really draw. I could kind of animate, but it was clear that my mind thought more technically. I liked scripting. I liked writing little Mel scripts up. I just liked building rigs, and honestly, that was, 12, 13, 14 years ago now, and I just haven't not rigged or scripted since then. Yeah, so that was how I kind of got started with tech animation. Does anyone else have a story?
Like basically the same story. Yeah.
I kind of wanted to come from I came from a very generalist background. I learned how to like model and animate and rig in like this very like survey-ish course, and I was put into my first game dev class, and because I was the only one that had taken an art class, I was then the artist forever. I was just always the artist, and eventually I started trying to like figure out new ways to like optimize my workflow, because I was the only artist that I would be given on a team, and that made me really like I gravitated to technical stuff, but I didn't really have a channel for like where that is going to take me. And I was just like, I was rigging something for a project once, and I was Googling like rigging tutorials, and I found Rigging Dojo, and Brad and Chad and those guys like really like took that idea of like, hey, like you have this like technical mind, and you really want to do something with it, and you kind of know a little bit of rigging already, and like just go for it. And they gave like a framework for like technical art success. And yeah, they really kind of like saw that side, kind of like we were saying. It's like I just really always was gravitating towards it, but it took somebody with a structure around it to be like, hey, no, you can do this really well. You can do this. Yeah.
I'll add something. So I went through school as an artist. I really wanted to do something with art. Had a little bit of programming background because I really like computers. And I got, into the game industry, and I ended up doing animation at Volition with Tim Borelli. And one of the first things he tasked me with was to take all this existing mocap from these previous games and see if we can get them to work with this moveset that we need now. So my job was trolling through folders and folders of Punisher mocap and some other things, and that was super tedious. And one of the biggest things that I wrote that we used for probably 8 or 9 years was a mocap explorer. So essentially collated all the files that we had for mocap, put it into a nice little window that you could scroll through and search and all that fun stuff. And then from there, it kind of evolved itself into a much bigger tool that facilitated like our whole kind of mocap process. So we'd load it, see if we like it, go to the next one, set the end clips, scale the thing, and then it's like almost animation ready, except for bookending animations and stuff. So ended up doing more and more stuff on that project that optimized and made our pipeline more efficient. And the opening came up on another project, and I left him for good. So.
So would you say that Tim Borelli gave you your wings to fly away?
No.
Oh. All right.
I made those freaking wings.
Well, with that being said, I believe our time is up. Again, Evan Cox, Brian Viniski, Nina Fricker, Randall Hess. This has been the Technical Animators Workshop. Thank you for watching. And next up is an interview with Sophie.